Hello everyone, my name is Aditya Udyavar and I'm someone who took digital logic just like you and have been through the process of learning VHDL. Today I'll be helping you get up and running with VHDL with the goal of addressing any confusion you may have along the way. First, I would like to set the scene and make it clear what VHDL is and how it is different from a programming language like Java or C++. First off, VHDL is a specialized language. It's a hardware description language used to describe and test circuits. Other languages like Java are more for general purpose programming. Another thing to note is that VHDL runs on special simulators, while programming languages can be run on just about any computer. The last and most important point is that VHDL code is not designed to be run by itself. Since you're designing a circuit, the only way to run it is to test different circuit inputs and see the value of the outputs. Alright, with these concepts in mind, let's go to our IDE to learn how to use this language. The environment we'll be using is EDA Playground. Alright, to get to EDA Playground, go to edaplayground.com and then go to Log in the top right. Now press this button to register for a full account. Then use your school email to create an account. Now I'm logged in and I'm on the home page. It might seem like a lot at first, but we'll take it one step at a time. Go to the top right and press the button that says Playgrounds and then Published Playgrounds. You can choose any example program from this list, but for this video, I'll choose VHDL Basic OR Gate. Here you can see a nice example of an OR gate coded in VHDL. Now I'm going to show you how to run this example. You might notice that if you press Run on the top left, you'll start seeing some text in the console. But this isn't really helpful and only tells us that the test was successful. Instead, go to the sidebar and check the box that says Open EPWave after Run. Now go ahead and click Run again at the top. Now you'll see the waveform diagram for our OR gate. Pay attention to the AIN and BIN inputs as well as the QOUT output. The blue line indicates a 0 and the tall green line indicates a 1. We can see that if either AIN or BIN or both signals are 1, then the output, which is QOUT, is also a 1, which is consistent with an OR gate. The waveform diagram is important to understand so you can see what your circuits are doing. Take a second to pause and then analyze this waveform diagram and make sure it's consistent with an OR gate. Now let's X out of the waveform. We now know how to run the code, so now let's actually understand what's going on. More specifically, why do we have two files called testbench.vhd on the left and design.vhd on the right? Like the name suggests, the design file describes the behavior of the circuit. In other words, the design.vhd file is what the circuit actually is. The testbench file simply tries different combinations of inputs on our design and confirms that the output is correct. It's testing the design we made in the design file. So when we're looking at the EPWave diagram, we are actually seeing these different combinations being tested. Without a testbench file, you will not be able to test your circuit or view the EPWave diagram. Alright, by this point in the tutorial, we have covered how to run VHDL code, why it is formatted into two different files, and how to look at the waveform in EDA Playground. Now let me show you some important settings to set in the sidebar in order to run your own VHDL code. First, make sure the language is set to VHDL. The top entity should be the name of your test bench. Usually it's just called testbench. And for the simulator, there are a lot of options, but the Aldex simulator is the best choice. Finally, make sure you select Open EPWave after Run if you want to see the waveform diagram after running your code. If instead you would like to download your HDL files after running, then check Download Files after Run. Now that's all the resources you need to get up and running with VHDL, as well as how to find a simple Hello World-like design to base your programs off of. Thanks for watching, and I'll see you later.